There is substantial evidence to show that aging causes changes in body water composition and that renal function and thirst perception on average decline among older adults. These three factors account for the prevalence of dehydration among the older adult population. Dehydration is not only a common but also a very serious condition in older adults. Mortality of patients with dehydration is high if not treated adequately, and in some studies exceeds 50%. These findings demonstrate the importance of timely diagnosis and adequate treatment of dehydration to reduce its serious effects on older adult patients.
Our device measures the relative conductivity of a user's urine as well as the frequency of urination over time. This aspect of urinalysis testing usually is only done a few times a year, and this device provides a more consistent and individualized alternative. After researching dehydration sensors on the market, we found that current solutions only focus on a single type of dehydration measurement. Dehydration has many indicators, so we decided to combine two of the most important indicators into our device: frequency and conductivity.
The main inputs to our device include an analog input that comes in the form of a conductivity sensor that has two wires wrapped around a probe. There are also two digital button inputs, one that simulates a flush and would be integrated into the actual flush mechanism of the toilet, and the other is a button that the user would press whenever they or a caretaker wanted to know their daily statistics. There's also a real-time clock module that keeps time from the moment the device is installed. In terms of outputs, there's an LED that flashes red when the urine is too conductive, and there's an LCD screen that displays current time, day, frequency, and conductivity readings.
The first time the device is turned on, it prompts the user to place the probe in a clean toilet bowl. It then takes a conductivity reading and uses that as a baseline conductivity for comparison purposes. At this time, a threshold value is also determined. The real-time clock will always be displaying the time on the LCD as well as the current and frequency reading. With every flush, the sensor records a conductivity reading before urine leaves the toilet, and if this value is over the baseline, the frequency is incremented and the conductivity is recorded and added to a daily running average. If the reading exceeds the threshold conductivity, the user is alerted on the LCD and the LED flashes red. Every day the running total is reset based on the real-time clock reading. When the second button is pressed, the daily average conductivity and frequency are displayed, as well as a hydration diagnosis based on the combination of these variables.
To simulate a urination, we added salt to the water. You'll notice that the conductivity went up when the salt was added to the water. When the user flushes, the frequency is incremented and the conductivity is added to the running daily total. Now we're going to add some more salt to simulate a urination with dangerously high ion concentrations. You can now see that the conductance is well over the threshold conductance. So when the user flushes in this situation, the LED flashes red and a danger warning sign is flashed on the LCD. So we're going to simulate a couple more flushes so we can demonstrate what the second button does. When the second button is pressed, the LCD displays your hydration recommendation. This is based on how low your frequency value is and how high your average daily conductivity value is.
An advantage of our device is that it shows dehydration measurements over the course of a day while still being able to alert the user of unusually high conductivity measurements in a single instance. Because it uses relative conductivity, the device can also accommodate many different water sources. This also can be a limitation because of the variability in urine and toilet bowl volumes. However, the device should work for a standard 6-liter flush. The design still lacks the ability to detect other indicators of dehydration, and it is bulky and corded. It is also intended for use in one toilet, so it assumes that the user is using just one toilet throughout the day. After addressing these limitations, we know that this device can easily be integrated into the lives of the elderly population. For example, these sensors can be placed in each personal toilet in places such as retirement and nursing homes, hospitals, and private residences. We hope that this could help keep the elderly healthy and promote a higher quality of life. Thank you.